It's truly one of Earth's most peculiar species, mankind. They've built special wards for giving birth to their young, with advanced machines and instruments monitoring the delivery. And they seem to be onto the secrets of the very process of conception. The cervix of this female is actually too narrow to give birth to a child, and the sperm of the male are too few and too slow to produce offspring. Nevertheless, they're about to become parents of a fine, healthy young boy called Adam. After 6 million years of evolution, the inventiveness of mankind has secured the reproduction of the species. And round the corner are new technologies that may affect their evolutionary progress even more radically. The world into which Adam is born is very different from all previous ones. Only a few generations ago, human living conditions were completely different.
Okay, well here's a summary of what really used to go on. The beloved Anne, the beloved daughter of James and Anne Abbey, they died the 4th of October, 1866, aged 16 years. Let's find somebody else. Okay, here we have Thomas Smith, died aged 19, and then we have young William Smith, died aged 15 months.
Many of the tombstones here at St Pancras Cemetery in London have one common denominator. The people underneath them died very young.
This graveyard, like any ancient graveyard, is a textbook of life and death. It's how life and death used to be. And you can put figures on those processes by going to the gravestones and just seeing how long did people live. And if you go around this cemetery, you find that people died young. Even 100 years ago, about one British baby in 2 died before they were 21 years old. So the ancient pattern of life and death was you were born and the chances are you wouldn't survive.
Today, living conditions in the developed world are completely different. We seem to have reached a point where our inventiveness can keep everyone alive.
Well, now the figures are entirely different. If you look at the patterns of life and death for a newborn English child born in the hospital just a few hundred metres from here, if it lasts for a month, and the first month can be difficult, it's got a 99.5% chance of lasting to 21. And that's a revolution in human life. It's actually also a revolution in human evolution.
But what impact does this have on evolution? How is the human species affected by the fact that everyone is able to survive, to reproduce, and to pass on their genes?
Well, Darwin's theory really turned on differences in the ability to have sex, to reproduce, to pass on genes. And to have sex, it's kind of helpful to be alive, right? So an awful lot of the children who died here young just never got to the age when they were going to have sexual reproduction and pass on their genes. So many of those deaths, so tragic though they were the raw material for the Darwinian machine. Now, because everybody stays alive effectively, then there's no fuel for natural selection. So natural selection, the engine of the Darwinian locomotive, has really died. It stopped.
But that statement may not be entirely correct. Geneticist Bruce Lahn made a discovery the other year that attracted much attention. Our genome seems to be still undergoing spectacular changes.
We have found a few brain development genes, their signature of very recent selection. That recent selection obviously indicates that it is possible that the human species, and specifically the human brain, might still be acquiring new properties.
To understand Bruce Lahn's discovery, We'll have to rewind the tape a bit, to the birth of mankind. Fossils show that our species came about around 200,000 years ago, somewhere in the Rift Valley in East Africa. DNA analyses of various ethnic groups have shown that this was our original home.
All of us alive today are the leaves at the very tips of this tree or bush, and we trace back into ever deeper branches on the tree until we get back to the deepest split in the tree right above the root, and that occurs in Africa.
About 50,000 years ago, a man was born here in East Africa. Scientists call him M168, and his offspring started to spread out all over the world.
He lived probably somewhere in Eastern Africa, possibly along the Rift Valley in Ethiopia or Kenya or Tanzania, and he lived probably 50 to 60,000 years ago. And he was the immediate ancestor of the first people to begin those tenuous movements out of Africa.
In a few thousand years, human beings from East Africa populated large parts of Asia and Australia. And just how the colonization of the planet occurred can be traced through the migration of the ones that came after M168.
These are M9 individuals coming up into Central Asia 40,000 years ago, around 35 to 40,000 years ago, very soon after that. M45 appears, which is the uniting marker for both the Native Americans and the Europeans, occurred in Central Asia. And the ones who turned west and headed into Europe gave rise to M173 en route, probably around 35,000 years ago. And they are the ancestors of most Western Europeans today.
Well, certainly, as humans sort of spread out of Africa and around the globe, there were a whole bunch of new kinds of challenges that hadn't been faced before. So in particular, going into much colder climates and trying to deal with new kinds of food sources.
Jonathan Pritchard has made the most exhaustive study of the contemporary evolution of mankind. He's made a detailed genetic study of 209 individuals from all over the world, looking for genes that have changed since we left Africa.
Well, I think that one of the interesting things that's come out is that there are a number of examples of genes that have shown fairly dramatic evolution over that time span.
Compared to other primates, human beings are considered to be very similar under the skin. But the study suggests that since the exodus out of Africa, we have undergone an unprecedented period of genetic changes. Mutations have affected our body hair, our pigmentation, our skeleton, our immune system, and our metabolism.
Recording?
Yeah.
But nobody was quite prepared for the controversial discovery made in this laboratory.
So here we're setting up a PCR. In this case, the name of the gene is ASPM. We know that it's related to brain development because in people who have mutations in this gene that cause a loss of function of the gene, the brain of the individual would develop very abnormally.
Bruce Lahn and his team have found that certain genes controlling brain development are under strong evolutionary pressure. They are changing as we speak.
What surprised us is that the G form, based on analysis of a large number of individuals, appears to be very young. It's only about a few thousand years old. So in other words, a few thousand years ago, everybody on this planet had the A variant. And then one person, by random mutation, acquired the G variant from a single copy to a frequency of about 20-30% worldwide and approaching 50% in specific populations.